Hi guys, this is Sanjeet. In our last tutorial, we talked about how to set up and get familiar with the Unity game engine. In this tutorial, we'll be designing a simple level of our game and learning about the components that we have in our inspector. So first, I remember in the last tutorial, our prefabs, our cube prefab, let's drag it back to the scene. And in this, you can rename it whatever you want. So I'm going to rename mine player. Alright, so now I'm going to drag a game object, 3D, and go to cube. So what I'm going to do is, first let me move this over a little bit. What I'm going to do is basically just create like a simple block. This is going to be a very simple design of our game level. Make navigation easier of our screen. Alright, so make it easy. Move this over here. So what I did was basically I just Command D'd it. It just duplicated my object. If you have a Mac, just use Command D. For Windows, I think it's Control D. I don't know top of my head, but just play around with it. So in this, you're just gonna have to play around with the objects. So just have fun, play around, and explore with it. So I'm gonna first rotate cube parentheses number 2 to 90. So let's readjust our camera a little bit. Alright, let's make our camera come a little forward. Okay, that's perfect. So now what I'm going to do is go to Game Object, 3D Object, and drag a plane object down here. Let's reset the positioning a little bit to make this doable. You just gotta play around a little bit with the position. So now let's work on the scale. Okay, so 5 isn't the best. Okay, so that definitely looks like perfect. No, not exactly. Okay, that looks a little better. Not really, a little. Alright, sorry about this, taking a little time. Gotta make adjustments. We just have to make a little readjustments. Usually, when it comes to game level design, it's usually common to get this type of readjustments. You just gotta just reposition some objects to make it look a little more cleaner. Oh, ignore that. Okay, that looks a little doable. Alright, so now what I'm going to do is create an empty game object. So game object, create empty. And we're going to rename this. You can rename it whatever you want. So I'm going to call it game level object. And then let's just reset the positioning. Okay, so it's basically an empty game object. What this mainly does is it just organizes all our game objects we actually created. That's why it's an empty object. So I'm just going to put my cube in here. Oops. Plane can go in here. So can this. Put all the objects we created except our player inside game level object. So now what I'm going to do is just drag this to my prefab. Oh, I didn't mean to call this cube. I'm just going to rename this. I'm just going to rename this to block number 1. Just going to copy and paste the name. Alright, so now what I think we should do now is go to materials. We're going to get very creative with this. We're just going to change the design of our object. So right click, go to materials, and what material does is by changing the design, it just changes the color of our object. So what we're going to do is you can call your material whatever, anything you want. I'm going to call this player color, and you can choose whatever color you want for your players. So for my player, I'm going to choose green to be the color. So we're just going to color green. I'm going to drag it just right here. Apply it. So now when I look in my prefabs, it updated to green. Okay, so let's go back, create another materials, and let's create a plain color. And for the plain color, I think I'm going to pick blue. Let's do a little light blue. I can just take care of that here. Just apply it. Material, and let's call it block color. Didn't actually change. Let's actually recreate the block color. Okay, I'm just going to call my block color red. And you can actually drag and drop this material to your game object any way you want. You can do it, you can drag it on here if you want, or you can just directly drag and drop it to your scene view. So I'm just going to, whatever way is easy for you. Alright. Let's save this real quick. So now what I want to do is actually simulate gravity in my game. So see this add component? We want to add a rigid body component because when our object falls from the air to the ground, it should hit the ground. It should not go through it. We have a collider that definitely computes a collision. So from our inspector, our player object will know when to collide, but it doesn't know right now when to fall. So we got to add that gravity component. So we're gonna just search for rigid body. Okay, and see, use gravity is already checked. So let's uncheck it first. And see, because it's not, I unchecked use gravity, our game object's not gonna fall to the ground, which is not what we want. Consider like a real life scenario. When you drop an object, it doesn't go through the ground, it hits the ground. So we want to make sure our player object hits the ground. So let's just recheck gravity. Alright, so hit the ground successfully. So now let's play around with it. Let's see what actually happens if we remove the box collider. And if it just went through the ground. We don't want it to go through the ground. Basically what box collider is doing, it's passing the collision detection signal towards our player. So when we hit the play button, our player object knows whenever it hits any object, it collides with it. But what rigid body does is makes our object, when we want to simulate the gravity, we don't even have to code the gravity. It's already using the gravity at one time. When it hits the ground, it'll hit the ground. But if we don't have the box collider, gravity will still get simulated, but it's not going to hit the ground. It's going to flow through the ground, which doesn't make any sense. So let's get our box collider back. You can just search up the collider if you want, or if you want, you can just go to physics. And we have multiple types of colliders. It doesn't matter what collider you use. You can use sphere collider, capsule, mesh, wheel, terrain, or box. I think box is easy for this case, so let's just use a box collider. And now run it again. What do you know? The collision is back. Okay, so I remember last tutorial I explained cube and mesh renderer. So the cube mesh filter, like I said, it just initializes the filter design. What mesh render actually does is, as in rendering the object, what it mainly does is makes our object visible. So let's say if I uncheck mesh render, see how our player object is no longer visible? It still actually exists in the scene, only difference is you just can't see it. Mesh render is actually one of the components we use when we make first-person shooter games. So if you play games like Halo or Call of Duty or Killzone, when it comes to like telling the gameplay story, you can see the design of the characters, their faces, and like how they look like. But when you're playing the scene of the game, when you're playing the levels, it's a first-person view. So basically the only thing you see is the world you're moving into. We'll actually talk about how to make a first-person controller as we go through more tutorials. I know it may not make so much sense right now, but believe me, it will make sense as we go through more tutorials. It's actually not that hard to make a first-person character, but we'll get more into that as we actually go through more tutorials. So let me get our mesh renderer back. Alright. So let's just double check to make sure it works. Okay, so there's one more thing I want to make clear about rigid body component. Your rigid body component should only be attached to the player object. It should only be attached to the character that you play as in the character. So if your rigid body component is attached to any scenes that any objects we put on a game level object child, like to our block or our plane, your rigid body should not be inside any of these objects. What mainly should be attached here is just your collider. So let's say if I remove my mesh collider here, I'm actually just going to click copy because I don't want to go through all that trouble of finding it again. So see how the collision did not successfully work? It did not work because our player object has the collider. That has one collider component. So our player object will collide. So basically what's going to happen now is anything that collides with our player object, that with our player object, collision will successfully work. But anything that collides with the plane, it will not successfully collide because in order to have collision meet up with another collision, both objects must have the collision component. So basically, you would not you want to have your colliders checked into every game object because all those game objects are their own people, and those own people need a signal to know when they're going to collide with the object. So rigid body should only be applied because you're using gravity. Gravity should only be applied to the character you play as and to nothing else because you're not playing as a plane and you're not playing as a block or anything. Your object you play as is the player of our game, which is this cube. So your player, the person you control in the game, the character you control into the game, is what should be attached with your rigid body. I hope it makes sense. If what I'm saying right now does not make sense, definitely please leave a comment in the YouTube tutorial so I can easily try to answer it whatever way I can. So I hope I explained that very clearly. So now let's actually get into our C# scripts. I actually forgot to add one more component. It's called character controller. So we're going to go back into physics and add our character controller. What our character controller mainly commutes is the limit of our slope, our offset, our skin width, and our minimum move distance. our radius of the object, and the height. So basically when we attach this to our player, it's just going to compute some simple movements and some slopes. You don't really have to worry about it too much. That can really take care of itself. Alright, so let's go to monodevelop. So now what I'm going to do is I'm going to create a public float variable. So I'm going to say public float speed equals 3.0f. Now I'm going to create another public float variable called gravity. And we want to initialize gravity to 9.81f because apply some real physics into this. I'm sure if you took a physics course in physics, when it comes to gravity, the center of our distance from the Earth with our gravity is 9.81. So 9.81 should also be simulated the same way in the game, just like in the real world. It's very simple physics. There's nothing you really have to worry about. Just initialize it to 9.81f. Now I want to have a private method. A private method is basically in our code that when we initialize it to one certain type of variable with its own data, that data is the only thing in the variable that can access it. Nothing else can access it. So I'm going to create a private variable called private character controller and call it my controller. So my controller is the only method inside the character controller that can access the modifier. So now I'm just going to initialize my controller to void start. So this is for initialization. So when we're going to play our game, this is how the game's going to start. The my controller variable is going to look for our character controller game object component. So in simple words, so we're going to tell it my controller equals game object. So anything we have in our scene is a game object. So we're going to tell it basically in our script that whatever game object we assigned a script to, my controller variable is going to look for the my controller data field is going to look for the character controller component inside our player object. So we're going to say my controller equals game object dot get component character controller. So we're going to be our player is going to get the game object component. Our game object player is going to get the character controller component. All right. So now that's when we start the game. So now we want to update our game as we play the game. We want to update our player as we play the game. So as we continue, so as we are playing through the scene of our as we're playing through the level of our game, we want to make sure our player updates. So one thing we want to update is definitely the movement of our player, the translation. So we're going to call a vector3 method. Sorry, vector3 variable. We're going to say vector3, and then let's give it a name. So vector3 movement x equals input dot get axis, and we want to go vertical because we want to either go forward or backward, and definitely have quotations. So actually, before I actually start coding this part, go to your edit, so in your Unity scene, go to edit, project setting, and input. Alright, so look at your axis over here, make sure this is open, and our size is 18. So go to vertical. So the name is vertical. It has to be exactly the same way as vertical was set up in Input Manager. So vertical is the name of the axis right here. So we have to make sure the same way the name is spelled out, it's spelled out the same way in our mono development source code. So do you see the negative button down? So down is basically when we go backward, and positive is when we go up. So basically when we press the up button and the down button, it'll go forward. If we press up, it'll go forward. Down, it'll go backward. And the type we have is key or mouse button. The axis, it's definitely in the x-axis because we're either going up or we're going down. And the join number is get motion from all joysticks. So what that means is basically what what that basically means is that's a joystick for our computer, our keyboard. So if we were using an Xbox controller, we would be setting this up in a different way in the input manager. But right now we're just using our keyboards on our PC or MacBooks or whatever computer we're using. So yeah, I think I explained it clearly. If it's not clear, definitely please leave a message and I'll try to explain it best way I can. I don't know how to explain it in a better way, but hopefully it'll make sense as we go through more tutorials. So vector 3 movement x equals input.getAxis quotations vertical times vector vector 3 dot times vector 3 dot forward times speed times delta times time dot delta time. So what this is doing is, since we're looking, think of it as a geometry coordinate. Like think of it as a graph. We have a vertical axis and we have a horizontal axis. This is very simple math on a graph. So on a vertical axis, there's only an x coordinate. So if you're going up, that's a positive axis. If you're going down, that's the negative x-axis. So if you look at our input manager, what this is doing is basically it's what was and Unity already kind of took care of that for us. So whatever was built in our input manager. So basically what it's doing now is it's getting the input dot get access. So whatever axis we set up in our input manager, which was the vertical axis that was already set up, we're picking out what we just initialized in there. So vector 3 dot forward. So if we move the vector forward times the amount of speed we initialize it times delta dot times time dot delta time. So what that's doing is basically it's updating our frame every second as we move times the amount of speed we initialized it. So if we move forward the positive direction, it will go forward the positive direction. If we want to go forward the negative direction, then it's actually going to be going backward in that direction. It'll make sense actually when we play our scene. So now let's make vector 3 movement z equals input dot get access. So now same logic applies. Imagine a graph. If you need to Google up a graph, you can Google it up. Actually, to make it easier, I'll leave a link tutorial for a graph. So let's actually just Google up a simple graph. An image. Graph with x and y axis labeled. So something like this. Let's see which ones. Yeah, I think this one is more clear. So now we want to go horizontal. Same logic applied to our graphs. So if you're going to go vertical, forward, backward, so your negative axis and positive axis. So horizontal times vector 3 dot right times speed times time dot delta time. So same logic applies, only thing is in the horizontal axis now, if we move into the right direction, it's going to move right times the speed times our frame per seconds, which is what the delta time is for. If same logic, so now if we translate our vector right, it will go times the amount of speed times our frame per second, or if we go left, times the amount of speed times our frame per second. So now I'm going to create another vector method. So we're going to call vector3. And let me think of a good name for this. I'm going to call this movement. Movement equals, so now basically we want to transform our object. As in transform, we want to transform it into as we move each position of our object, we want to make sure it transforms to all that our x, y, and our z coordinates exactly at the same time. It updates our movements. So transform dot transform direction. And we want to do a little simple math. So we want to add our movement x, make this a little easier, plus movement z. Alright, so now what I want to do is I want to apply gravity. So let's leave a simple comment. I want gravity to update throughout our scene of the game every time we play it. And it could update any time. And we'll get into how gravity applies every time in our game. It could be like, let's say if we got shot off our screen, we want gravity to still get simulated, because if we get shot off our stage of the screen, we want to go down. We don't want to stay up in the air all day. So I'm going to say movement dot y minus equals gravity. So we want to simulate gravity times our frame per seconds. So time dot delta time. All right, and we also want to debug it. We want to have a debug log. So as we transform our object to every different position throughout the scene or game. So let's say if I want to move my object from, so when the game starts, if I want to move my object from one position of X, Y, and Z towards another position when I play my game, so when I'm controlling my character, I should be able to see in my screen how it's getting debugged. So I should be able to see at each position I move into. It'll make more sense when I actually show it. So debug. So we just want a message to show debug.log. So movement plus movement. So what this movement's going to do is add up our vector 3, our movement x and movement z, and basically it's going to calculate. It's going to calculate basically our x, y, and z coordinates. So now I just want one more method. So I just want to say my controller. I think it's my controller. No, it's not my controller. Character controller. Dot move. Ugh. Oh, I know what to do. This is actually some simple. This is actually some simple thing I'm forgetting. I'm just trying to remember. Okay, I think it should work now. Let's compile our code first. Okay, so let me think. What error am I making? I think I'm just forgetting something pretty simple. Hold on a sec. Let me just pause. Hmm. Let me look at one of my former codes. I have multiple projects, so actually, I know I forgot something pretty silly. It happened. This is why you should always like take notes of what you're doing. Okay, I just forgot a simple movement. That's all. All right, yeah, I know what I did wrong. So basically, I want my controller.move. I want it to move my movement method, my movement variable I created with vector3. So basically, what this is gonna do is, as much as it's gonna debug our movement position, what it's gonna do is it's gonna initialize our movement x, z, and y coordinates move all together at the same time. So basically, when we control our character, what the my controller move is gonna do is it's just gonna make our character move. It's just gonna initialize it to get the message that when we want it to move, it should move any direction from forward, backward, left, and right. The build got a little canceled. Okay, so the build was definitely successful. It's definitely giving an application output. All right, let's stop the scene, and let's look in our script. All right, so our script definitely looks updated. So now what we want to do is we just want to add this script to our player. So what I'm gonna do is just drag and drop it. So now I think this should make more sense. So in the code, when I used my controller, when I made the character controller variable and named it my controller. So when I wanted to start the scene, I wanted the my controller data field from character controller. So basically, when I attached this script to my player object, I wanted for my player object, I wanted so when this script was attached to my player object, I wanted my controller to find the component character controller that was attached to my player game object. So it definitely did that, I can tell. It definitely is going to do that, I can tell. And then basically just update our frame per second. Alright, so let's test our game to see if it works. Ooh, it's not moving the way I wanted. Alright, so I think I know what the problem is. We gotta freeze the rotations because with rigid body, as well as it simulates gravity, when we move our characters, when we use our like left, right, and up and down arrow keys, we don't want our character to rotate. We just want it to move in a normal position, like we move like when you play games like Call of Duty and Halo. When you use the joystick to move your character doesn't rotate at the same time it's moving. You just want to translate the vector. You don't want to move anything else. You just want to translate and move a position. You don't want to rotate. So let's try again. I press my up arrow, it's moving forward. My down arrow, it's moving backward. My left arrow, it's moving left. It's moving right. All right, so let's actually check our input manager to see if actually we're right. So let's look at my horizontal. Okay, so see this negative button? the left button was already set up. So when we actually use vector 3.right position, when we set up our horizontal axis, we didn't have to tell it to get the left key and the right key. We just had to call the horizontal axis and then just make it translate the vectors 3 position dot right times the speed times time dot zelda time. And same for our vertical axis. So basically, up, down, left, and right they were already built in for us. We just had to initialize the getaxis method in our code. We just had to code it inside monodevelop and then just run and compile it. So let's just test it one more time. So left, right, forward, backward. And actually look at the screen over here. So do you see at the same time as we move, as our position moves, do you see when we initialize debug.log? So basically what this does is when we run our game in the Unity game engine, when we hit play, a debug method shows up right here. So see the movement script right now? It's actually updating it's updating the transform.translation of our movement. So let's move position to the left. So see how it keep updating? Forward, backward, left, right. Our movement is keep showing up in the log. It keeps debugging, letting us know how much we're moving. That's basically what debug.log does. It just underneath here, it just tells us a simple message. That's all. So yeah, our game object definitely works successfully. Our player is moving. It's it's definitely what we expecting it in the game object in our game scene. So my goal in the next tutorial is not only to try to explain this in a better way, because I can tell if some of you are probably going to watch this tutorial, and I hope it doesn't happen. Some of you might feel a little confused, but if you feel confused, please leave a comment. I will definitely try to answer the best way I can, and we're all here to learn. So thank you for watching. In the next tutorial, we're going to try to make a first-person character, and I think we might start getting into programming projectiles. We're going to probably first design the projectiles and then learn how to have like mouse looker and how to fire a simple projectile.